Okay, so this video is about double angle formulas. All right, so if you see sine of 2x, you might think, oh, it's pretty simple. It's like something like 2 sine of x. But it's a little bit more complicated than that, and let's think about what it actually equals to. So sine of 2x is actually the same thing as sine of x plus x, right? Because x plus x gives you 2x. And what we learned in the previous lesson is there's a rule for expanding the addition of two angles with sine. And the rule says sine of the first angle times cosine of the second angle. Coincidentally, they're both the same thing. So sine of x times cosine of x plus cosine of the first angle times sine of the second angle. So if that's true, you might notice sine x times cosine x and cosine x times sine x are really the same thing. So if you understand this, there's a little understood 1 in front of this. So it's 1 sine x cosine x. And this is also plus 1 more sine x cosine x. All right, so we've got 1 sine x cosine x plus another sine x cosine x. Leaves you with 2 sine x cosine x's. And that's the formula, that's the rule. Make that 2 look a little better. So the rule for it is sine of 2x is equal to 2 sine of x times cosine of x. And that's what we can use it to find the exact value of things. All right, so that's the formula. I'll get that written down where all the other formulas and identities are. It's really useful. It comes up in expanding and simplifying these identities. All right, let's talk about cosine. Oh, I would copy all this down if you didn't already know it, because I'm about to erase the screen. All right, let's think about this in cosine of 2x. All right, so if we think about cosine of 2x, we could think about it the same way we thought about sine. But we could think about that 2x means x plus x. So if that's true, we've got to remember the cosine formula for expansion. And it's cosine of the first times cosine of the second plus, or actually sine changes, so subtract sine of the first times sine of the second. So you get cosine of x times cosine of x. Well, the cosine of x times the exact same thing is cosine squared. So you can think about this as cosine of x squared. Subtract sine times sine is the same thing, times itself, just sine of x squared. And what we already know is one of the identities say that if I have this thing being squared, I can simplify it and call it cosine squared x. Subtract sine squared x. So the formula for cosine of 2x is this. So cosine of 2x is equal to cosine squared x subtract sine squared x. Kind of nice to know. It's kind of close to sine squared plus cosine squared equals to 1, right? But it's a subtraction sign, so it's something completely different. But suppose we thought about that another way. Let's take the fact that cosine of 2x equals to this. We can derive other formulas. There's actually 3 of them. So this is another formula for the exact same expression, cosine 2x. All right, let's use the fact that cosine of 2x is equal to cosine squared x subtract sine squared x. All right, now what we know is that the identity, Pythagorean identity says sine squared plus cosine squared equals to 1. And we've solved this for sine. So what we decided was sine squared x equals to 1 subtract cosine squared x. This is one of our identities. We've solved that before. So technically, where the sine squared is, I can replace it with what I know is equal to. I know it's equal to 1 subtract cosine squared. So I could take this cosine squared x, subtract the substitution of sine squared, 1 subtract cosine squared. And you come up with this, which is an equation I can simplify, right? So I distribute the negative sign of both of those, making it cosine squared x subtract 1 plus cosine squared x, right? Because the negative times the negative is positive. So we got a cosine squared plus another cosine squared. Well, that's 2 cosine squareds. So 2 cosine squareds subtract 1. So another formula for this, cosine of 2x, is 2 cosine squared x subtract 1. Might as well write it all the way through. So cosine of 2x equals this as well. So we got 2 formulas of cosine of 2x. We got this one, and it could also be this one. Both of them are useful at different times. All right. Now let's think about the third formula, the final formula for cosine of 2x. All right. So erase the screen. Let's think about it another way. Suppose this is the same formula, cosine of 2x is equal to cosine squared x subtract sine squared x. All right, let's go back to what we know about this. What we already know is that if I had sine squared x plus cosine squared x is equal to 1. So if I solve this for cosine instead, we already did this before, but just remember the cosine squared x is equal to 1 subtract sine squared x. All right, it's kind of hard to see, but I'll make it look better. 1 subtract sine squared x is what cosine squared x is equal to. So everywhere I see cosine squared x, I can substitute it. So if I took this, I replace cosine squared x with 1 subtract sine squared x. I subtract sine squared on the end. I wind up with this expression. So what you have is 1 subtract sine squared x subtract sine squared x. There's no number in front of the parentheses, so I can drop it off. So what I have is a negative sine squared x plus another negative sine squared x. So 1 sine squared x subtract another 1 sine squared x is a negative 2 sine squared x. So a third formula for cosine of 2x is this. Those are 3 formulas you can use for cosine of 2x. Each one has its own usefulness. All right, so that's it. That's all I have about that one. I'll pause the video and copy that down as a note. All right, so the tan of 2x formula, I'm going to leave it here. I won't bother deriving it, but the formula for tan of 2x is 2 tan of x divided by 1 subtract tan squared of x. All right, let's actually put these formulas to use. All right, so the example says find the exact value of sine of 2x if sine of x equals 3/5. So the best way of doing this is expanding sine of 2x first. Let's first figure out what that is. We're going to use this back later. But we know sine of 2x is equal to 2 sine of x times cosine of x. Now, it would be really great if we knew what sine of x and cosine of x was. It's nice they told you what sine of x was. Sine of x is 3/5. Meaning everywhere I see sine of x, I can replace it to its equivalent, 3/5. So it's 2 times 3/5 times cosine of x. Now, if I know sine of x is 3/5, let's think about what cosine of x could be. Sine of x is 3/5. This is 3, this is 5, this is x. So this is a triangle, and opposite is 3. The hypotenuse is 5. And the adjacent side, you might just know this is a 3, 4, 5 triangle. If you didn't know, you use Pythagorean theorem to figure out this third side. You use a squared plus b squared equals c squared. And you would have said 3 squared plus b squared equals that 5 squared. And you do the math, and you get b equals to the square root of 25 subtract 9, or b equals to 4. So anyway, That's what it is. B is 4. All right, so if that's true, then cosine of x is 4/5. But technically, though, if you remember, sine could be positive elsewhere. It could be positive 3/5 over here. So I could have had -4. I could have got -4/5. So technically, it's two different answers for this. All right, so I'm going to simplify it and just say x is in quadrant 1. That way we don't have to focus on both answers, just focus on one of them. So only one we consider is the triangle formed in quadrant 1. Ordinarily, they would have described this earlier, so you didn't have an ambiguous situation where it could be 4 or -4. All right, anyway, that being said, what we have is 2 times 3/5 times 4/5. So this is 2 times 3 is 6/5 times 4/5 is 24/25. So that means the sine of 2x has to be 24/25. All right, so that's how we apply it. We use the formula, expand it, and that's it. All right, so that's all I have, and good luck.